Dear viewers, I welcome you all for yet another lecture session on the topic high performance liquid chromatography. So high performance liquid chromatography, it is a separation technique which involves the injection of a small volume of liquid sample into a tube packed with tiny particles where the individual components of the sample are moved down the packed tube with the liquid forced through the column by high pressure delivered through a pump. The column packing is used to separate the components from one another. It involves various chemical and physical interactions between their molecules and the packing particles. The separated components are then detected at the exit of the column by a detector that measures their amount. And this diagram represents the various elements present in a HPLC equipment. So it includes the solvent reservoir which holds the solvent. Then you have a pumping system which infuses the pressure into the solvent, and you have a sample injection system to inject the sample. This is the HPLC column which acts as a stationary phase, and this solvent acts as a mobile phase, and you have a detection system followed by a data acquisition system. So we'll go in depth about each and every component of this HPLC equipment. So the basic components are a solvent reservoir for the mobile phase, and you have a pumping systems to force the liquid phase through the column, sample injection system for the introduction of sample in the mobile phase, chromatographic column with an appropriate length of stationary phase, detection system for the identification of sample components as they elute from the column. Then you have a microprocessor or a recorder to provide a readable signal which is proportional to magnitude of the amount of each component present in the analyte. So coming to the solvent reservoir, so it holds the solvent which is the mobile phase here, and they are contained in a glass or a stainless steel reservoir which contains 200 to 1000 ml of a solvent, and the mobile phase of a solvent is usually a mixture of polar and non-polar liquid components whose respective concentrations are varied depending on the composition of the sample. And the flow of this solvent from the reservoir will be in the form of pulses. So the solvent from the solvent reservoir has to be injected into that column, and that is done by the pumping systems. The main characteristics of any the pumping systems in HPLC includes it should generate pressures of up to 6000 psi and a moderate flow rates of 0.5 to 2 ml per min, pulse free output, and a corrosion resistant components. And this is a type of pumping system which is used in an HPLC. So just have a look at this diagram. Here this is a piston, a motor driven piston which moves in this hydraulic chamber. So on the backstroke of the piston, this valve, ball check valve, this valve is open, which causes the flow of solvent from the reservoir to this hydraulic chamber during the backstroke. So at that time this valve will be closed, this valve will be open. So the solvent will be flow from the solvent reservoir to this chamber, and during the forward stroke of this piston, this valve gets closed and this valve gets open causes the high pressurized solvent to move to the column. So as we have seen that the solvent will be in the form of pulses. For a smoothening, flow smoothening has to be done, and that is done by a pulse damper. So let's discuss about the pulse damper now. So this is a pulse damper or a flow smoother. So this is nothing but a chamber where it holds an inert fluid, and there is an impermeable membrane is separated by the space is being separated by an impermeable membrane. The pulsed mobile phase will be smoothened here, and you will get a pulse free mobile phase output, and this pulse free mobile phase output will carry the sample. Through this pulse mobile phase only, the sample will be injected. Now let's have a look at the sample injection system. So in this HPLC, sampling valves and loops method is being used to uh, inject the sample into the column. So when the valve is in this side, so can you see here, this is the valve. So this is the valve mechanism. So when the valve is in the left side, the sample is injected into that syringe, and when the lever moves from left to right, the sample will be injected into that loop. It will be injected into the loop. So thereby the sample is drawn into the syringe when the lever is in left position, and the lever is moved from left to right position, the sample will be injected into that loop. So this is how sample injection is done. So once the sample injection is done, the mobile phase along with the sample will move to the column. So the columns are usually made of polished stainless steel, which is around 50 to 300 millimeter long and has an internal diameter between 2 and 5 mm. And they are commonly filled with a stationary phase with a particle size of 3 to 10 micrometers. The columns with an internal